Hello? Is this working? Can you hear me back there? Okay, good. Today I'm gonna talk about how can we achieve comfort in architecture by mimicking fungi and lichens adaptation techniques. First of all, what is biomimicry? Well, nature have been conducting research for the past 3.8 billion years on what is appropriate for our environment and what is not. So, simply, biomimicry is getting inspired by nature. Or, in Janine Bennis' words, innovations inspired by nature. To get started with this, we need to ask three main questions. What, where, and how. What? The aim behind this project is achieving thermal and light comfort in a human living space. Where is the question defining our case study. Located in Sharjah, UAE, the case study chosen for this project is placed in a harsh, hot climate with northwest privilege wind. The building chosen is a residential villa with its main entrance facing southeast, leaving it with a huge deal of direct sun radiation exposure, while at the backyard it have a lot of potential harnessing most of the location's favored wind. While its modern design will make it easier trying to implement fungi mimicked solutions, enhancing its comfort. How? How is the project's main question that we have previously answered by mimicking fungus. This time we're answering the question, what is fungus? We're all familiar with mushrooms and yeast that we use to make bread. But these are only two examples of a diverse kingdom of fungi. They are a group of organisms that are completely separate from animals and plants, and they can be unicellular like yeast or multicellular like mushroom. First of all, how do they live? Fungi are similar to animals in the sense that they are heterotrophs. This means that, unlike plants, they cannot make their own organic compounds. Instead, like us, they have to consume it from their environment. But working on its own is not always enough for fungus to extract all the nutrients it needs. Instead, many team up with plants, and in some cases, neither can survive without the other. These interactions are known as symbiosis, produced through photosynthesis in return for phosphorus, magnesium, and copper, collected by the fungi from the soil. Lichens. What are lichens? Well, a lichen is the product of symbiosis between algae and fungi. Let me show you how lichens look like. So, what are mushrooms? Mushrooms are fungal fruit bodies. Through the gills on the bottom part of the mushroom cap, they release spores that can either germinate on their own to form a new individual by asexual reproduction, or the spores can join together to form a new organism, thereby reproducing sexually. Having flexibility to reproduce asexually or sexually is a great advantage that allow fungi to exploit stable conditions or adapt to changing ones. Of course, you're now thinking, how can such information be helpful? Well, let me guide you through it. Strategy number 1. Lichens, as was mentioned before, are products of algae-fungi symbiosis. as an algal cell is held by a fungal hyphae, where the algal cell produces carbohydrates, exchanging them with the fungal body for minerals, structure, and protection. Where the fungal body, in our case, can represent the building shell as a lightweight structure fixed on it, holding a double skin of vegetation, forming a double green wall. But still lichens exchange power, doing a more efficient process that we want to mimic by replacing plants with photovoltaic cells, which in turn can provide the building with power. But that is not all what we can benefit from the gap behind the PV cells, as we can use it as an insulation layer, or even better, allow air circulation through it, increasing the building's heat loss by convection and enhancing the building's thermal performance. This is the building's thermal gain and loss analysis before applying the strategy. While after applying our first strategy, we can see that the building's reaction to radiation and heat gain are significantly less. Strategy 2. Still with lichens. As beside lichens' structure of hyphae and algae, there is a thin fungal layer covering the algae cells, protecting them from UV rays and from getting dehydrated. While scientists have discovered a great resemblance between this fungal screen and the textiles used for tents and shading, which can as well protect from UV rays and dehydration, creating an outdoor space with an enhanced comfort experience, and would be most convenient in the backyard of our case study, increasing the thermal comfort as well as reducing the building's exposure to direct radiations. And here are our second strategy analysis results, reducing the heat gain even more. Strategy number 3. Mushroom gills work as the duct from which spores are released in order to be carried by the air, while gills regulate the motion of air under the mushroom cap, controlling both its speed and direction, allowing a smooth takeoff for the spores and preventing them from sticking back to the gill. As from this ability came the idea of using the tent-like structure implemented in our case study's backyard to harness the favored wind while repelling unwanted wind away from the backyard.